Hello, I'm Laura Lewis. Welcome to this class on kinetic energy and equations for moving objects. So we'll look at how to rearrange and substitute values into the equation for kinetic energy. Also apply the equation to exam style questions and use this equation alongside other energy equations such as potential, especially gravitational potential energy. Okay, so let's have a bit of a recap on the kinetic energy equation. So we've got kinetic energy, or KE for short. So that's actually energy in joules, and any energy is always measured in the unit joules. That's very important. Okay, half, that's just a number, half, or 0.5 times m, that's the mass, usually in kilograms, okay, times velocity squared, and velocity is in meters per second. That squared is very important. Often people miss that when they're doing calculations. So we'll go straight into an example. So a bird of mass 2 kilograms, that's the mass, is flying at a speed of 10 meters per second. What is its kinetic energy? Okay, so first of all, always write out the equation, kinetic energy. You can just write KE, people know what you mean. It's half times m times v squared. Okay, so I'm substituting the numbers in before rearranging. So K is half times 2, that's the mass, times 10 squared. Okay, so first of all, half times 2 is going to be 1, and 10 squared is 100. So it's very easily is 100 joules. Okay, that's a very straightforward one. Okay, so to get a little bit harder, so a meteorite has a speed of 6 meters per second. The energy is 120 joules. Find the mass. Okay, it's just a diagram showed that it's moving an arrow at 6 meters per second. So we'll always write down what we know and don't know. So mass we don't know, I put a question mark, V 6 meters per second, and KE 120 joules. So again, always write out, so exams always write out the kinetic energy equation. You can get a mark just writing the correct equation out, and also people know what you're doing. So KE equals half times m times v squared. So this time we've got kinetic energy. We've got 120 joules, capital J, is half times m times 6 squared. That's really important, okay? So that squared bit. Okay, so I'm going to times by 2. First of all, that's what I've done there. Times by 2 to get rid of the fraction. So 2 times 120 is 240. So we're just left with m times 6 squared. 6 squared, we can just work that out 36. So we divide both sides by 36. Divide both sides by 36. We get 240 divided by 36 is m. And m, you can do it on a calculator, 6.6 reoccurring kilograms. That's fine for the science, okay? So another example, so a little bit more involved again. So a cat has a mass of 5 kilograms. It has an energy of 100 joules when it runs. So remember, kinetic energy is always moving objects. It could be anything. It could be a person. It could be a meteorite. It could be anything. How fast does it run? Okay. This is in 2 parts. It's a bit of a longer one. So KE again, half times m times v squared. You can shorten it to half. So if you, when things are written together, okay, so half times m times v squared, you can just write it as half mv squared. Okay. So I've got a pen. So 100 joules equals half times 5 times v squared. Okay, so again, we're going to multiply that up. Let's go to the next slide. So yeah, I wrote it out again for you. 100 joules equals half times 5 times v squared, times by 2 to get rid of that fraction. So you get 200 joules is 5 kilograms times v squared. Is that v squared? That's the important bit I keep highlighting. Divide both sides by 5. So you get 200 divided by 5 is still v squared. You get 40 from that, it's just a number, is v squared. And to get the velocity, you have to square root both sides. So v is the square root of 40. Okay, v equals 6.3 meters per second. Again, on the calculator to do that. The last one, okay, going to combine 2 different formulae here, different equations, often seen in exams. So a box is lifted 50 meters above the ground. It has a mass of 20 kilograms. What speed would it fall if it dropped? Well, it's fall at if it dropped. Okay, assume G equals 10. So that's gravitational force is 10. So first of all, we need to find out how much it's got. So you need to use two equations in this. So the first one is gravitational potential energy, GPE shortened to mg delta h. So delta means a change in height, so we're lifting it up. Ke, what we saw before, half mv squared. So how much gravitational potential energy was there? So GPE is m times g times delta h. So 20 kilograms is a mass, 10 is gravitational field strength on Earth, times 50, that's in meters. Okay, that's 50 in meters. Okay, so GP is quite high here, we've lit along like 10,000 joules. Okay, that's the gravitational potential energy just for part one from lifting it up. So assuming we've got 10,000 joules before, we're going to assume all GPE is converted to kinetic energy when it drops. Okay, often you'll see it will be all converted. Okay, obviously this is an ideal situation. We'll talk about in real life why may not happen. So 10,000 joules is half times m times v squared. So we just put it equal to it because they're both energy. Okay, so again, times 2 by that, times by 2 to get rid of the fraction. 20,000 joules, 20 kilograms times v squared. So, but divide both sides by 20 here. I didn't want to step here. Is v squared. And then we square root both sides. So v is square root of 1,000 this time. So v equals 100 meters per second. So we can say about why would we not actually get that in real life? Okay, so we wouldn't get this in real life because we've been an ideal situation because not, so example, you had a question saying why would the box not fall at this in real life? Bit of a bonus question, because obviously we've looked at an ideal situation here, assume all is converted. In real life, a lot of energy is wasted in terms of heat and air resistance will play a part. So it wouldn't, this is ideal situation, it wouldn't reach that in real life. But obviously for purposes of this calculation, it's fine. Okay, so thank you for listening and see you in another video. Goodbye.